not going to write up the whole thing that we did yesterday, because we got through the whole problem, I think, right? Calculating an empirical formula. Okay? I am going to run through very quickly what we did. So, in the question, you were given percent composition by mass, right? And then step 1, I said, if you're given percents, assume you have 100 grams of compound, because then those percents become masses. And step 2 was convert those masses to moles. And step 3 was divide each of those moles by the smallest number of moles to get at least a whole number ratio for at least one of them. So as it turned out, the smallest number of moles was potassium, right? Okay, and so that was definitely 1. The chromium ended up becoming really, really close to 1, enough that we could round it to 1, right? But and then many times, however many elements there are, they almost, most times they are all going to come out to whole numbers, and you're just done, okay? But there are some times when you get one that's going to be a decimal, like we had yesterday, so that's why I use that as the example, because it covers all the possibilities. And in that case, we tried to look for a fractional equivalent of that decimal. Now, I also used an example in which it came out really easy. I mean, it turned out to be pretty what? Didn't it turn out to be really close to 3.5 for the oxygen, right? Yeah. Of course, 0.5 represents fractionally 1/2, so we just multiply the entire thing by 2 to get rid of that half. Okay, you guys remember the whole process, right? All right, I do want to go through some other possible decimals that you guys are going to run into that I don't want you getting your panties in a bunch about and trying to freak out. What if, just for fun, you don't have to write this down unless you desperately want to, but what if we came up with something like 2.19 for one of the elements? Yes, because 0.19 is very, very close to 0.2, which is 1/5, precisely. What if we came up with something like 3.68? Why? 0.68 is really close to 0.67, which, as Robbie just said, is essentially 2/3 multiplied by 3. So look for things like that, okay? If you get a decimal that's not roundable, and you got to be within a couple hundredths or less to be roundable, okay? Look for the fractional equivalent of some sort of decimal. Okay. Next. I also said to you yesterday that I always like to give you guys, when I teach you how to do something, I always like to give you at least one, if not more, to try on your own so you can kind of get a feel for it before you leave. Well, obviously we didn't have enough time to do that yesterday. Plus, we also have to learn how to do molecular formulas. So, in order to get to the molecular formula, you actually have to do an empirical formula first. So what I'm going to do is give you a problem for you guys to try on your own to do the empirical formula for, okay? And then I'll show you what to do to get to the molecular formula from there. So here's the next example. Don't write this down. Don't write it down. I got to check my recently created notes. Yes. Yep. There's a sentence that I'm not going to give you right now. And here in a little bit, once we've actually found the empirical formula, To get to the molecular formula, you need more information. I'm going to fill in that blank. Okay, so give yourselves like a line full of blank there. Now, currently, you don't know how to do the molecular formula. So if you could take that information and find the empirical formula first, we'll check where you are, and then we'll go from there. And Megan has absolutely no idea what's going on. I know the answer to this, but I'll ask anyway. Have you looked at the videos yet? I know. They are there, is what I'm saying. They're available. So if you look on, I believe, Monday, there's one, and on Tuesday, there's one. And I have a really good feeling it'll make sense to you. Oh, sorry. Oh, look at that. Blaze rages near Bel Air, UCLA, and Major Art Museum. C2H5? Is that what you got? C2H5? Right. Just ask. Is that what you got? For the empirical formula, did you get C2H5?
Oh, I didn't finish. No, I forgot one part.
Oh, the actual empirical formula part.
Yeah.
Everyone got C2H5? No? Really? What'd you get? I'm just asking, what'd you get?
I have C1H3.389, but I still
Ooh,
remember
that's
I didn't like switch
weird.
over.
That's weird.
Oh, no, that's not my final answer. Oh,
No, that's weird that you have that as part of a way to get to the final answer. Elise, what do you have? What do you have? Just tell me what you have. Just tell me what you have. No, just tell me what you have.
All I ever have is C1H3.389. I didn't get, I have
H3.419. We're doing it the way.
Come look at mine. Come look at it.
No.
Yes. What do you mean no?
Ah!
Oh, you messed up?
Oh, no.
What did you do?
Does anybody check my math up here?
No. Just assume you know what you're doing.
Oh.
This number is correct.
Okay.
Oh. Oh, it actually equals 110.
Yes, it does.
Yeah.
Okay, let's all redo this now.
Sorry about that.
Well, now you have to.
Really?
Ooh, Jason's upset. That is awesome. I'm glad you're upset. You know why? You just said, really? Do you know why I'm glad?
Makes you doing it?
Did you do it? Why would you change it if you're not going to do it?
You ran away.
Where did you go? What number?
That's not Jacob, my last name. Dr. Jacob. Oh, okay, Dr. Jacob.
I guess you want to. Oh, that's because you were here. So why? Our friends don't know. Yeah, but this is really easy, so you should probably do it.
Oh, isn't it?
Yeah, I'm just having the time of my life. I don't know about you, but I think this is great.
What numbers are people using?
I think so.
What's these like 101?
It's just because you can't ask any questions. So like, you get confused about something, but like you can't talk. What do we do after we get the one point? Like, okay. Okay, so I think after that. I can't stop the video. No, what I'm saying, like, if you have a question, you can't just like stop the video. Like, oh, I have a question. I don't remember half of it.
No, I didn't.
Actually, no, I don't. That actually works.
Okay.
Oh, because I put one for.
Maybe he was saying that because of the
That's partially from this class, and then
No,
once
that's
you
what he told us to use.
government,
What? He's trying to told us to use that. He's like,
What grade do you have a
no, maybe it is.
They can
What?
We have an academic report all the time. And it really bothers me. Like when my teacher goes to everyone's grades and does that long list, because that rounds up to.
But
Hey, Rantington!
oh, he's here. He's right at card.
H5.
Landon just kind of ran away.
I don't know. There he is.
I don't think he answered my question.
Thank you. Okay, so What'd you guys get here? What'd you get here? 2 what? 2, 4 something, wasn't it? 2, 4, 6. Okay. You can't have too many significant figures when you're doing this part, but you can have too few. I'm just saying, if you're going to make a mistake on significant figures, go big. Okay, so now we have carbon 7.131, we have hydrogen 14.246. We divide each of those by the smallest, which automatically converts the carbon to 1 and the hydrogen to 2. There you go. There's the empirical formula. Yes. Yeah, and again, what I'm saying is, technically the correct number is 4. But if you're going to screw up, go big. Because if you screw up going not having enough, that actually could influence your actual answer. Yeah, because it doesn't matter anyway, because this is what we're looking for. So we have currently determined the empirical formula. Yes?
One slight question, although I got the answer in the end.
Yeah.
Wouldn't we have 1.01 as hydrogen rather than 1.008?
You mean like the 1.01 that I put right there?
Yeah.
Yeah.
That would get you 14.217. So.
Okay. Well, then somebody screwed up. Who screwed up?
No, because on our thing it's 1.008, so that's what we
Yeah, but the very first day I handed you the periodic tables, I said, round all of them to the hundredths place. Okay, now, for those of you that did the 217, what did you get? Well, as Trinity already said, it doesn't influence the result, right? So anyway, there we go. So there is the empirical formula. Everyone hunky-dory? Pretty easy process, would you agree? Again, I'm going to ask, what if I had given you grams here instead of percentages? You just convert to moles. Right. I'm just saying, don't freak out if you see that, because you're going to see that. All right. So now, how do we do the molecular formula? In a separate experiment, don't write that down. I'm just letting you know. There are experiments that can do this piece. There are, laboratory experiments that can do that. There are techniques that can do the next part. So this would be actually 2 separate techniques that would be used. So in a separate technique, laboratory technique, it was determined that its molar mass is 42.08 grams per mole. There's a very strong likelihood that you're going to learn one of those techniques. I know in my AP class we do like 3. But anyway, what do I do with that information? Well, let me back up a little bit and talk about what we did yesterday. You don't have to write this down because you already have it written down. C6H12O6. Does anyone remember what that refers to? See this again? Glucose. Glucose. Okay, this is glucose. Is this an empirical or molecular formula?
yeah.
I can't reduce that?
You can't.
I can reduce that. It is its true formula. That is the formula for a glucose molecule. What would its empirical formula be? We did this yesterday. H2O. Okay. You have a calculator. please find the mass of that? Do you feel comfortable with that? Okay, find the mass of this, CH2O. Do you feel comfortable with this?
No.
Do you? Oh gosh. Do it. Find the mass of this. The molar mass. Sorry about that. So how was the geometry exam? Nothing. Just kidding. I was just kidding. Just kidding. Did that make you a little mad? Dang it. I'm trying to light a fire under you. Not happening? Huh? All right, so I forget who. Chancellor, what do you got? Okay, or Hannah, what do you have? Oh gosh, who did I ask to do this?
Hannah and Chancellor?
Please, somebody do this one. The mass of this.
I did it wrong.
Okay, I got it. 30.03 grams per mole. Just tell me 180.18. Okay, good. 180.18 grams per mole. Okay? The formula mass thing that we just did like 2 or 3 days ago. Okay, that's going to be a thing for the rest of your life. Or chemistry life, anyway. Okay? So, did this get reduced by a factor of 6? Well, it has to be that way, right? Doesn't this have to be 1/6 of that, since this is 1/6 of that? Where I'm going with this is the molecular formulas are going to be, the formula itself is going to be a multiple of the empirical formula, and the masses of the empirical formula to the molecular formula are also going to be a multiple. Okay? I'm giving you the molecular mass, molar mass. What factor am I going to multiply this by to get to the actual molecular formula? Do you see where I'm trying to lead you to have an understanding of why you're about to do what you're going to do? So, what you're going to do to get to the molecular formula is you're going to either need to be given this, and for the time being, that's the only thing that we can do because you guys don't know enough other chemistry to get to that from other experimental data. So I'm going to have to provide this for you, okay, for now. You're going to take that, you're going to divide it into the empirical formula mass. So you need to find the mass of this. Okay, so you take the molar mass, divide it by the empirical formula mass, and that's going to give you some factor. So in this case, it's going to be 42.08 divided by, did anybody get the mass of this yet? Okay, it's 14.03. 14.03. And 42 divided by 14 is 3. So we're going to multiply this entire thing by 3 to get C3H6. C3H6. Empirical formula mass. Okay, it should be relatively logical. You guys clearly understood this part, reducing this by a factor of 6, which means the masses are reduced by a factor of 6. we figured that 6 out just by, dividing one by the other. We don't, to get that number, we're going to take the molar mass that's given in the problem, divide it by the empirical formula mass, which we can find by after we found the empirical formula, divide those two, get the factor that we're going to multiply this by. I don't know if you guys have figured this out yet, but we went backwards. When we were doing the percent compositions, you had the formula, we found the percents. Now we're taking the percents and finding the formula. Okay. Well, it would be good for you guys to practice this. And Megan rudely did not distribute these when she was over here. Yes. Pardon? Yes, that's why I said yes.
Is this both or is it just like one of them?